All right, children. Um, we are going to actually prove the fact that you have been using about how vertical angles are congruent, which we know is the same as equal. We've used it in class before, and we've solved problems with it, but now we're going to actually prove that it's true. So find this picture on your paper, and what I'm going to do is I'm going to label this guy on the left angle 1, and this guy on the right angle 2. And I know that sometimes in our pictures those angle swoops mean that they're equal, but we're just going to kind of pretend that they're not there because we're going to prove that they're equal. So I have angle 1 on the left and angle 2 on the right. And then the nice thing about pictures is that even if something isn't there, you can still label something. So even though there's not a marking right here at the top, I'm still going to label this angle 3 so that way I can work with it and can talk about it. Okay. So very first thing I'm always going to put is whatever is given to you. So angle 1, angle 2 are vertical angles, and I'm going to do the angle symbol with an S so that I don't have to write out angles. And then your reason is given. Okay. And even if that wasn't given to you, like even if this problem was just the picture and to prove, you could still say this because people will just assume that what you see in the picture you assume is true, and vertical angles is one of those things. But so we have those vertical angles. And if you look at this picture and you highlight the sides of angle 1 and the sides of angle 3, you get, when you put them together, this kind of straight line right here. So angle 1 and angle 3 make a line. So in my step 2, we're going to say two things in this line that are similar. So I'm going to say, let's see here, angle 1 and angle 3 are supplementary. Hopefully you can read my handwriting. It says supplementary. Okay. And I know that because I look at the picture and they make a straight line. And one of those things that you're just allowed to assume is that if something looks like a straight line, it is. I think this thing that kind of slants up and down looks like a straight line. So I'm just allowed to assume that it is. So 1 and 3, since they make that line, are supplementary. And then the same sort of thing happens. I'm going to get rid of some of this so it's not as gross. So look at that was 1, this is 2, that's 3. The same sort of thing happens if you highlight the sides of angle 3 and the sides of angle 2. You just get this other line. Okay. So also in that same box, I'm going to put that angle 2 and angle 3 are supplementary. And it's for the same reason. They make a line, and we're allowed to assume that lines are supplementary. The angles that make lines are supplementary. And so in my reason, number 2, I'm just going to put that. I'm going to write angles that make lines are supplementary. Hopefully you can read that. If not, you can let me know in class. Okay. So you're like, oh, Colin, what does that do for us? Great. We talked a little bit about this yesterday, okay? We said when you have a fancy math word on the left over here, like supplementary is a fancy math word, you probably are going to use the definition. And we said yesterday in class that supplementary means things that add up to 180. So this first little sentence about angle 1 and angle 3 are supplementary. I can sort of transform it and make that say measure of angle 1. Remember the M means measure. So measure of angle 1 plus measure of angle 3 equals 180. Because they make a straight line, they have to add up to 180. And then I can say the same thing about this bottom line. I can say the measure of angle 2 plus the measure of angle 3 is also 180. And so for my reason, we use that supplementary means things add up to 180. So I'm going to say for my reason definition of supplementary. Oh, I'm going to run out of space. Okay, that's fine. All right, now notice both of these things are equal to 180. So I should be able to make them equal to each other. So in my step 4, I'm going to say the measure of angle 1 plus the measure of angle 3. But instead of saying it equals 180, actually, hold on. I'm going to erase this and write smaller so that it will all fit. Okay. Measure of angle 1 plus measure of angle 3 equals. But then instead of saying 180 like I did up here, I'm going to say measure of angle 2 plus measure of angle 3. Because they're both equal to 180, so they should be the same. Okay. And then 4, you could say a couple of things. You could say substitution, because I took out a 180 and put in something that I know it's in the place of. Or you could say slash. You could call this the transitive property also. Either one is correct. It just depends on what you like better. Okay. We're almost done. You guys are doing good. Okay. Now, both of these things have a measure of angle 3 in them. And because it's a number, you can subtract it. And if you subtract a measure of angle 3 from each thing, you have measure of angle 1 equals measure of angle 2. And to get that, we did subtraction. Anytime you're talking about the measure of an angle, like we are right here and right here, we're talking about a number, and you can subtract numbers. So I subtracted a measure of angle 3 from both sides. And then last step, because we have angles that are equal, that means angle 1 is congruent to angle 2, which is what we wanted to prove. Hooray. And we can say something like angles with equal measure are the same, or equals a not so fancy word for congruent. It's up to you, however you want to say this. So I'm going to say equal measures congruent angles. And so now, because you have proven that vertical angles are the same, you can use them in really whatever you want. We had been using it in class, but now you can actually use the fact that vertical angles are congruent for things. And officially, this is called the vertical angles theorem. So hooray, good job.